So I was just diving into this project about optimizing Kubernetes pod placement, and it's mind-blowing how it addresses network latency.
Right. It's fascinating that Kubernetes can struggle with scheduling when it doesn't consider network topology outside the cluster.
Exactly, I mean the basic issue is that the scheduler doesn't know where resources are located, right? It just assigns pods randomly.
Yes, and that's a real problem, especially if your database is in a different availability zone than your application.
Wait, seriously? So if a SQL client pod is scheduled randomly, it could end up with high latency just because of its location.
Absolutely. That's the crux of the problem. The solution makes Kubernetes aware of network topologies using a lookup service.
Oh, so this lookup service resolves an external resource's domain name to an IP and maps it to a network zone.
Exactly. It can inject node affinity rules when a pod is created, ensuring it's scheduled in the same zone as its external resource.
Wow, that sounds genius. But doesn't that make certain assumptions about the availability of those resources?
Good point. It assumes that the external resource's FQDN resolves to a single IP in a known subnet, which might not always hold true.
Right, so if that IP changes, would that break the whole system? It sounds a bit fragile.
It can be. The solution addresses this by using a mutating webhook to dynamically adjust node affinity.
And that helps maintain optimal placement even when external resources move around. That's a pretty smart workaround.
Exactly. The performance impact is huge, too. They reported a 175% to 375% improvement in transactions per second.
Wait, what? That's massive for latency-sensitive workloads. How do they even measure that?
They used a benchmark tool called PG-Bench, which simulates database load and measures performance metrics.
That's interesting, but I wonder about the trade-offs. I mean, could there be situations where this approach backfires?
Definitely. In a multi-AZ scenario where resources might move frequently, relying on static node affinity could cause issues.
So if a resource goes down or gets moved, would that require constant updates to the pod specifications?
Exactly. That's where the automatic nature of this solution shines, reducing manual intervention significantly.
I love how they implemented it with a simple Python lookup service. It feels very accessible for developers.
Totally. And deploying it with Kubernetes just makes it easier to integrate into existing environments.
But what about on-prem setups? Would this work in data centers without cloud infrastructure?
Surprisingly, yes. As long as the necessary metadata is available, this approach can be adapted for on-prem environments.
Interesting, so it could potentially help optimize network performance even in traditional data centers.
Absolutely. It's like having a smart traffic controller for your Kubernetes pods.
And yet there's a complexity trade-off. More components could mean more points of failure, right?
That's true. With increased complexity, you also need to consider security implications and maintenance.
I can see how that could become a management headache. So are there plans for future enhancements?
Yes, there's talk about supporting multiple A records, which would further enhance flexibility.
That sounds promising. It seems like this project has the potential to evolve quite a bit.
For sure, it's definitely a step forward for improving performance in Kubernetes environments.
So if you were to sum this up, it's essentially about making smarter scheduling decisions, right?
Exactly. By leveraging external network data, Kubernetes can optimize pod placement and reduce latency.
And it's all about ensuring the best possible performance for latency-sensitive applications.
Yes, plus, it's a great reminder of how network architecture impacts overall application performance.
I love that perspective. It makes you think about infrastructure choices at a deeper level.
Definitely. It's a great example of how we need to be mindful of the environments our applications operate in.
So do you think this solution could solve a lot of the challenges we see in cloud-native setups?
I believe so. It's a significant improvement for applications that require low latency communication.
I'm really excited to see how this evolves. It feels like we're just scratching the surface here.
For sure. and it encourages developers to think critically about resource dependencies and placements.
Right? It's all about connection and awareness in the infrastructure layer.
Exactly, and with these insights, we can better design our systems to handle modern demands.
I can't wait to see what comes next. This could really change how we approach Kubernetes deployments.
Absolutely, and who knows, maybe it'll inspire similar innovations across other cloud platforms.
That would be amazing. It's clear that optimizing for performance is becoming a top priority.
And that's a great takeaway for listeners. Thinking strategically about performance can lead to significant gains.